All right, francium phosphide. So first we got to figure out what its chemical formula is. And I noticed francium is a metal and phosphide is a non-metal. So that's given me a hint that I'm probably going to be dealing with an ionic bond here. But let's see when we actually write it out. Francium is Fr. It's in group 1, so it has a +1 charge. Phosphide is a -3 because it's in group 15. So there are 3 franciums for 1 phosphorus, and it is indeed a ± or an ionic bond. So we know that francium is going to be giving 1 electron each to phosphorus to fill up phosphorus's shell. So when we write this in the ionic Lewis structure, we know that cations we're just going to write without any dots, and we had 3 of them. And phosphorus, we're going to write with 8 dots because it filled up its shell. And we're going to have the charges on the outside. Okay, so francium 3 of a +1 with phosphorus with full octet of -3. And now we're going to prove it with the process. We have 3 franciums. They all have 1 dot because they're in group 1. And they're going to 1 phosphorus, which has 5 valence electrons because it's in group 15. Okay, so this first francium is going to go fill this first gap. Second francium fills the second gap. Third francium fills the third gap. And that's why we're showing it here. It's emptied its outer energy level. So we're going to show it empty here. Technically, it is still full because its new outer energy level is full. But we're showing that the outer one that used to have 1 is now empty. And phosphorus used to have 5, now has 8 after those transfer of electrons. And now that bond can have electrostatic attraction.